Example 19 talks about a company that's producing chili powder. And the profit for the company each week is based off of how many kilograms of chili powder that they sell. So that's X kilograms. So that's X is still our independent variable. It's just units are kilograms. And the profit is a function P, which is defined to be P of X equals 48X plus 1.4x squared minus 5/100ths x to the 2.8 power minus 270. So this equation right here tells us the profit of the company based on how many kilograms of chili powder it sells. All right. P of X is measured in dollars and it's valid for the domain of 0 to 80. Okay, so which makes sense because they're not going to have a negative amount of chili powder which would be produced, and apparently 80 kilograms might be the most that the factory is capable of producing. So how many kilograms of chili powder must the company sell to maximize its weekly profit? And then we want to justify our answer. Okay, so we're looking for the absolute max. All right, even though it doesn't say the word absolute, we see maximize and absolute is not necessarily to be part of the problem. We're looking for the absolute max though. We have two candidates ready to go, 0 and 80. All right, so we're going to be interested in P of 0 and P of 80, but we have to figure out if there are any other candidates. Those candidates will come from critical numbers. And the critical numbers occur when the derivative is equal to 0. So let's find our derivative, P prime of X. 48x derives to 48. 1.4x squared, as we do with the power rule, becomes 2.8x. And then we have minus, and we have 5/100ths times 2x to the 2.8. So we're going to multiply the 5/100ths times 2.8. Do that in the heads on the calculator. We're going to get 0.14x. And then the new exponent, well, the old exponent is 2.8, so we're going to subtract 1 from that. So the new exponent is 1.8. And then we have minus 270. That's a constant, so that will derive to 0. So here's P prime of X, and we're interested when P prime of X is equal to 0. Now that is a problem that we're going to let the calculator figure out. So let's go to the calculator. Bring that onto the screen. All right. And we'll go to y equals. You can see I've actually already got the formula in for y1. We're not going to use it at the moment because we want to use the derivative and figure out when the derivative is equal to 0. So I got the derivative right there in y2. Now notice that the equal sign for the derivative is highlighted, which means the function is active and on. But for y1, the original function, it's not active. What I've done is I've gone up to the equal sign and I hit enter, and you can do that. Now I just turned it on, and now I'm going to turn it off again. The reason why I'm turning the graph off is because I don't want to see the graph of the original function right now. I'm interested in when the graph of the derivative is equal to 0. Remember, we've got our 0 finder that we can use here. But before we do that, let's modify our viewing window. So I'm going to move this over ever so slightly. See that we're only interested in x values from 0 to 80. So I'm going to go to Window, and I'm going to make my x min a little bit less than 0. So let's just say negative 5. And my x max, I'll make that 85. And just because I've got to cover 90 units there, I'm going to go by tens for the tick marks. Oops, it's kind of hard to see there. Sorry about the glare. All right, as far as the y, min, and max are concerned, we're interested when the function crosses the x-axis. So we can keep these numbers small, but if you want to see the overall graph of the function, we can do that as well. We just have to do something when y min doesn't need to be all that small, but y max might be a little bit larger because we're looking for profits overall. So let's just make it 2,500. All right, and the y scale will go by 500. Again, that doesn't really matter all that much. The key is that we're looking in between 0 and 80 right there. Okay, so now if we pull up our graph, all right, we see the graph of our, well, that's way too high, so I guess we don't have that much of a profit here. So let me change my window just quickly. I'm going to make my y max, let's make it, well, let's just make it 250 instead, and we'll have y scale go by 25s. See if that makes things a little bit better. There we go. All right, so here's our derivative. And we can see that it clearly crosses the x-axis somewhere in this area. We know the x-axis, we have our tick marks going by tens. So 10, 20, 30, 40, 50. So it's a little bit before 60 is when our derivative is equal to 0. Let's find the exact value. So we're going to activate that calculate menu. So we do second trace to bring up the calculate menu, and we want option number 2, our zero finder. All right, it asks for a left bound. Now we already know that it's happening somewhere between 50 and 60. So let's just make the left bound 50, although we could go smaller. We'll make the right bound 60, although we could go larger. So now we can see the lines there that are saying, okay, I'm looking in between these two lines. Obviously our answer is closer to 60, so we'll call it 59. So I'm going to guess 59, and there's my actual answer. The derivative is equal to 0 at 58.358152. So let's go back here. Put this right there for the moment. All right, and we know this happens at x equals 58.358152. So that is another candidate. Okay, so now we have 3 candidates. We have to find P of 0, P of 58.358152, and also P of 80. Okay, so we want to find out which one of these produces the maximum value. We have to plug these 3 values into the original function, which is why I had tried covering up without the glare from the window there. We go back to y equals, and notice that our original function is in y1. So I'm going to go to the main screen, and I'm going to pull up my y variables. So alpha trace, the green alpha button, and then the trace key, y1, hit enter. And now in parentheses, I'm going to put 0. That means that we're plugging 0 into the original function. Now we already know what this is going to be, because if we plug 0 into the original function, all the terms except the last one are going to go to 0, so our answer is going to be negative 270, and you can see there it absolutely is. All right, and it would make no sense for us to produce no chili powder, because how are we going to make any profit at all? So that is not going to be our maximum value. Now we can plug in the remaining values. So let me see if I move this over. Here we go. That's a little better. All right, so now we're going to do y1. So I'm just going to just go up and hit enter again on it. And I'm going to type in 58.358152. And that gives us a profit of $2,893.04 if we round to the nearest penny. All right, and finally we're going to do y1 of 80. So again, just go up, hit enter, y1 of 80. And that gives us a profit that's not as much, so $1,873.32. All right, so we've got those as our 3 candidates. We see that this is the maximum value. So last but not least, let's answer the question. And the question says, how many kilograms of chili powder must the company sell to maximize its weekly profit? It doesn't ask for the weekly profit, it asks how many kilograms. And that means we are looking for x equals 58.358152 kilograms. Okay, and that's based off of this information right here. It does say justify your answer, and that's true. Now on the exam and on this problem, justifying the answer means performing a candidates test. So this data right here, that is your justification. You are showing the reader that you checked all the candidates, the endpoints, and the critical number.